Okay, we're looking at the final page of the Chapter 10 tests. Question 10 says, if a function f of x, right, if f of x is a function whose domain and range are all real numbers, what is the difference between f of x and f of x plus 10? Be clear and justify your responses completely. So let's take a look at a function over here in GeoGebra. And you can see this is just some basic average function. I think it's a third degree polynomial with a couple different coefficients. But this satisfies the situation we're talking about. All values of x have y values for them. And I may have to zoom out a lot, but eventually this line will go anywhere I want it to the right. And same thing if I go down and I look this way, right? Eventually this line will hit any number I want it to out on the left. So it has all values are in the domain, and clearly everything's in the range, right? You can see it taking off in both directions pretty much forever. So the question is, if I take this function and I essentially uh, add 10 to it, so I'm just going to type in my input box f of x and then plus 10. So what happens precisely is every single point, right, is increased by 15 units. It's kind of difficult to see this, but especially like in places like right about here. Let me, I think there's a pen I can grab for this. Right here. No, I thought there was a pen. Oh yeah, here's a pen. So I can look at this. So clearly I can see 10, 5. If I'm at 5 here, right, on the origin, I add 10, I'm at 15. But what about a point like this? You can see right here y is the number 8. And if I add 10 to that, I'm going to follow this straight up, and you can see it goes up to the number 18. So by adding 10, it increases by 18. Let's take a look at, I think this is a pretty good looking spot right here. So this, right, it's, what is it? Y is 16 at that point. The output is 16. And if I add and I go up to it should go to 26. I'm just going to follow this line up. And yeah, sure enough, if I follow it all the way up, I can see that it's landing right at 26 there. So um, basically, what happens is I get the exact same curve, except everything on the curve was shifted up 10 units. Um, and it is kind of difficult for me to see that, especially when I'm looking at how it looks like these two lines are getting closer and closer to each other. But I mean, it's always a matter of looking at a point and then looking at the point directly above it or below it. On lines that are parallel to the y-axis. So basically what happens is we end up shifting this function up 10 units. So if f of x is a function whose domain and range are all real numbers, what is the difference between f of x and f of x plus 10? Be clear and justify your responses completely. So this seems like a lot of text, so I typed it instead of writing, but what I wrote is f of x plus 10 will be the exact same shape as the function f of x, but will be shifted 10 units above it. And I was looking for that as part of your answer. Shifted 10 units up, just the idea that it's moved vertically 10 units above where it was. The outputs of f of x are all increased by a value of 10. So what would have been so for example, if you had an output value that was 5, when you subject that to the function f of x plus 10, the output would be 15. So that's pretty much what's going on there. Okay, let's look at question number 11. It says, Principal Perez suspects that one of his math teachers, Mr. Roberts, gives too many A's. He casually asked 300 Math 1 students from the two Math 1 teachers what grades they got for the first semester. The results are in the table shown below. Based on this information, are you more likely to get an A from Mr. Roberts than you are from Mr. Bigelow? Explain completely. Well, I think one of the things we can see here is that Mr. Roberts has 32 students who received A's, and he has a larger class too. The question is that enough to overcome the A's that Mr. Bigelow gave? So if I was to look at, I'll type this as an equation, 32, and then I'm going to divide that by 152, right? That is, that's the, what is it? That's the proportion of students that received A's. And I could do that for B's, C's, D's, and F's. Let's see, in this program, I think I could just hit draw, hit math. and ask it to evaluate it. Well, it reduced that to 4/9. So what I'm looking for is kind of what that is as a percent. So if I look at 32 divided by 152, it ends up being about 21%. So I would say that about 21% of the students in Mr. Roberts' class got an A. Whoa, class. And you know what? I hate that vocabulary. Earned, EARNED, and A, and uppercase A. While on the other hand, he had a smaller number of students, only 148, but 14 of them received an A, and that comes out to about 9.5%. So 9.5% of the students in Mr. B's class earned an A. I would say that you're more likely to get an A if you're in Robert's class, just based on this particular groups of students. Doesn't mean at all that anything other than that's just what happened, right? If you're just selecting a student at random, that's what we're likely to see. Now, the thing that's interesting about this question is part B and C are really kind of redundant. They're basically asking the first thing. They're asking essentially the same information that A presents, right? So it says if one of Mr. Roberts' students is chosen at random, so that means these are all of Mr. Roberts' students. There's 152 of them. And if one is chosen at random, what is the probability that the student got an A for the first semester? Well, that's exactly the same thing, right? It's still the 32 out of 152, which is about 0.21, which is about 21%. So that's the probability. 21% of the time I would expect, if I'm choosing one truly at random, that 21% of the time I get one who said they had an A. For Mr. Bigelow's class, it was 14 out of 148, which is 0.095, which is about 9.5%. So, so how do I know? I guess I could say, how I know probabilities is it's the number of outcomes that I'm looking for, right? Favorable outcomes. In this case, favorable outcomes would be an A out of total number of possibilities, right? So in Robert's class, the possibility there's 152 different people, and favorable outcomes getting an A would be 32. And that's not to say that other grades are favorable or less favorable. We're just saying that's what we're looking for. I could say, what's the probability of them getting an F? Well, in that case, the favorable outcome would be 9 out of 152. And we would take this number and divide it by the 152. So let's move on to the final question on the test, question number 12. And just real quick, one of the things that I observed, it's pretty simple, but it was a consistent error that I saw several people make. It turns out that anytime we have these diagonals, right, we can't just report those distances as easily as perhaps we want to. So we were supposed to find the perimeter, and we were supposed to find the area of this shape. And if you take a look at it, if I was trying to find the perimeter of this, I need to figure out how big this piece is right here. So I could look at this as a right triangle, and you can see I've got a leg that's 2 and a leg that's 3. So that area that I marked in a question mark would be the square root of 2 squared plus 3 squared, which is 9 plus 14, which is the square root of 13. So part of my perimeter is root 13. Another part that many of you missed was this thing right here has dimensions 1 by 1. And this piece is not a half. It's not 2, as some of you claimed. It is the square root of 1 squared plus 1 squared, which is the square root of 2. So that portion had a root 2 value. So if I look at the remaining parts, right, this thing right here has a length of 1, 2, 3, 4, 5. This has a length of 1. This has a length of 1, 2, 3, 4. Here we have a length of 3, and then this has a length of 1, 2, 3, 4. So my perimeter ends up being, if I write these down, I've got 5 plus 4 plus 3 plus another 4 plus a 1. And then I also have a root 13, and I also have a root 2. So I believe when I punch those in, I get that the perimeter, and I'll round this to the nearest tenth, is about 22.019 centimeters. The final part of this problem, and it's the final part of the test, was what's the area? And if I'm looking for the area here, I could chunk this up into a few pieces. So for example, this piece that I've just chunked off in blue is 3 times 4, so there's an area of 12 there. This little square right here has a nice clean area of 4. This square has an area of 1/2, right? You can see it's 1/2 of those squares. This piece up here, this, you can see this is a 3 times 2, which is 6, and half of that's 3. So the area is going to be 12 plus 4 plus 3. So that's 12 plus 7, which is 19, and then plus a half. So the area is equal to 19.5, and of course the units for that are squared centimeters. So that was the final question on this test. So give everything a good look over. If you have any questions or unresolved issues, please see me in class. This is Mr. Roberts. Good day.